Assalamu alaikum and a very good evening to everyone. I'm Fariha chowdhury, a final year undergrad student at the Department of Biomedical Engineering, BUET. Today, it's my honor to share our research on titled AI-based prognosis of HER2 status from histopathology images, which integrates IHC and H&E virtual staining. This is the presentation outline. Before moving on to our proposed solution, I'd like to start with the background and motivation of the problem. Breast cancer remains one of the most prevalent cancers among women in Bangladesh. Around 22.5 out of every 1 lakh Bangladeshi women every year is diagnosed with breast cancer. Breast cancer accounts for 30% of all female cancer and nearly 70% of cancer deaths among women in Bangladesh. Now, among these, 15 to 20% of cancer cases are tested as HER2 positive, which is an aggressive subtype of breast cancer. This happens because of the overexpression of HER2, which is a receptor which causes the cells to grow abruptly and rapidly. HER2 is an important biomarker because it determines eligibility for cancer therapy, targeted cancer therapy. Typically, HER2 grading is divided into 3 to 4 categories. A score of 0 or 1 plus means HER2 negative. 2 plus indicates borderline cases, which requires further FISH testing. Lastly, 3 plus means HER2 positive. Now, for the motivation and the challenges faced regarding HER2 detection, firstly, the inter and intra-observer variability in manual HER2 scoring. Secondly, we are aiming for a faster and more reliable cancer diagnosis because the whole process takes around 5 to 7 days from its testing to its scoring. Lastly, the high expense of the IHC test. These challenges led us to ask, can artificial intelligence extract molecular expression like HER2 from H&E slides, as H&E slides are routine histopathological tests done in cancer. This is why we are proposing a solution that can digitally stain H&E slides to predict HER2 scores, potentially reducing reliance on costly IHC and FISH testing. For our data set, we are working with BCI dataset. Since we are working with both H&E and IHC images, we required a dataset that has both paired images. BCI image qualifies for that. It has 4,870 paired images of H&E and HER2 slides at 124 pixels at 20x magnification. We have also started collecting data from Labit Cancer and Super Specialty Center under the guidance of Dr. Ali Nafisa ma'am. This is to ensure that our model is working properly on external tests as well. Now, I'll be explaining how our model will be actually working. Firstly, the translation model takes an H&E image as input. The translation model then generates an IHC image. The generated IHC image then goes to the classification model to predict the final grading. Now, I'll be explaining how we have trained our model for the classification and translation task. The translation task is based on generative adversarial network. It uses GAN to produce realistic IHC images. Firstly, the generator first takes an input image, then it generates a IHC image. The generated IHC image and ground truth real IHC image goes through the discriminator. The discriminator then assesses the similarities between both of these images. If it's not satisfied with its results, then it sends the images back to the generator. The generator then keeps trying on until the discriminator can no longer tell the differences between the images. A simple analogy would be to think the generator as an artist who's trying to recreate an original painting, and the discriminator as an art critic whose job is to criticize the artist and tell him to improve his work. The artist keeps trying on until the art critic is satisfied with the results. Now, after the IHC is being translated, it goes through the classification task. The classification model is trained in this way. The IHC images first goes through certain pre-processing techniques. It goes through color deconvolution, stain reconstitution, contrast enhancement, and finally resizing. This is to ensure that there remains no variability and no consistency in between the images. And then after that, it goes through certain oversampling and augmentation techniques. I actually forgot to mention that in the data set, there was a huge class imbalance between the classes, which means there was less data in class 0 and class 1, and there were more data for class 2 and class 3. To make sure that our model trains properly, we used weighted resampling techniques to make sure that in every epoch, similar number of images is going through the model. And then after all of these images are fed into our custom ensemble CNN model, which finally produces the logics for all of the classes. Moving on to the results. In the very left, you can see an H&E image. It goes through our translation model to produce a generated IHC image, which is in the middle. And in the right, you can see the ground truth IHC image. Looking at both of these images, we can see there's a high perceptual similarity between these images. Although there might be some differences, the overall HER2 expression can be understood from the generated IHC. This ensures us that our translation model is working quite effectively. Even after that, we tried to compare both of the images with both generated IHC and real IHC using some qualitative metrics like PSNR, which is peak signal and noise ratio. This was in a very good range for most of our data. The mean absolute error was also in a good range. Now, coming to our classification model, this is the model results this is the confusion matrices for our model. So in the left, you can see the classification matrix without any threshold. And in the right, you can see the classification matrix after applying a threshold of 0.7. The threshold indicating that all of the results are being predicted with 70% confidence. Even before applying the confidence score, it was actually performing quite efficiently. But after applying the threshold, the accuracy increased by a bit. This is the final overall results of our model. So we actually tried a lot of approaches before finalizing our ensemble CNN net model. As I have already said, that our model was performing very well. It achieved an accuracy of 97.13%, a precision score of 97.13%, and a recall and F1 score of 97.13% without any threshold. But with the threshold of 0.7, the accuracy did increase by a bit. It had an accuracy of 97.62%, a precision score of 97.63%, and a recall and F1 score of 97.62%. Now, in the top row, you can see a predicted class of an image with a confidence score of 1. We wanted to make sure that it is performing properly, our model is performing properly. To do that, we plotted some attention maps to see how our model is coming to a prediction. So in the very left, you can see a combined GradCam, which basically indicates the regions of interest, specifically where our model is actually giving focus for the final prediction of an image. We also validated our results with the help of our pathologist, Dr. Sifat Said ma'am. She ensured us that our model is actually focusing on biologically meaningful regions and not just randomly. Okay, so as I have explained, the novelty of our whole approach lies in its dual stage pipeline of it. This our model first takes an IHC H&E image and then translates it to an IHC and then subsequently classifies it. It also compares the HER2 grading performance between ground truth images and digitally generated ones. All of our work was to ensure that it can actually work as a helpful tool for doctors and histopathologists. It aims to help histopathologists to assist in flagging ambiguous slides and which need confirmatory testing. Our preliminary results showed very good potential, but we are continuously improving the image translation fidelity and our classification accuracy every day. Looking ahead, we plan to develop a web-based interface for pathologists to upload H&E images and subsequently classify it. We also want to expand the data set so that we can be sure of the results that it is producing. We also want to extend the data set for adding support for IHC biomarkers besides HER2, like ER, PR, Ki67. And we have already started collecting data from LabAid regarding this as well. We're collecting currently ER, PR, Ki67 and HER2 data. These are the key studies and papers that we have used for our research and that have guided in our research problem as well. Thank you to our clinical collaborators, Dr. Ali Nafisa ma'am, Dr. Sifat Said ma'am, and Dr. Foida Arzuman ma'am for their clinical support and data support. I'd like to thank Samiha Zoana Bapu and Dr. Ali Nafisa ma'am because for their help, we were able to came up with the idea. Thank you to my group members, Nibid and Shotota for their continued support throughout the project. And my sincere thanks to Dr. Tawfiq Hasan sir for his continuous guidance. Thank you so much everyone for your time and attention.